Today we're going to continue our study of limits by determining a limit numerically. So the first thing that we're going to do is review our objective, which is to use limit properties to find limits. The properties are listed here, and I should take a moment and review all of them. Let me know if you have any questions. Now that you've reviewed the limit properties, we can go ahead and do some examples so that hopefully they make a little more sense. So if we have the limit as x approaches 5 of 4, since 4 is a constant, it doesn't matter what you're approaching, and the limit will equal 4. For number 2, you have the limit as x approaches 2 of x. So we're looking at rule B. So since x is approaching 2, your limit is going to approach 2. For number 3, we have the limit as x approaches negative 3 of x to the 4th. So we'll use rule C and look at negative 3 to the 4th, which is 81. For example number 4, we're looking at rule D. Since the limit as x approaches 3 of f of x minus g of x, it's essentially the limit as x approaches 3 of f of x minus the limit as x approaches 3 of g of x, which is 12 minus negative 4, or 16. Number 5 goes with rule E, and so we're going to multiply the two limits together, and 12 times negative 4 is negative 48. 6 goes with rule F, and we're allowed to do the division as long as we're not dividing by 0. Since the limit as x approaches 3 of g of x is negative 4, we're in good shape. We'll do 12 divided by negative 4 and get negative 3. 7 is very similar to number 4, except that instead of subtracting, we're adding the two limit values. So 12 plus negative 4 is 8. 8, example number 8, goes with rule letter G, and so we need to take the limit value, and in this case square it, because there's a squared out here. So 12 squared is 144. And then example number 9 also goes with rule G. This time we're going to take the limit to the negative third. So negative 4 raised to the negative third power is negative 1 over 64. Okay, we'll try another set of examples, again using the rules. This time we're looking at the limit as x approaches negative 2 for f of x and g of x. For example number 1, it doesn't matter, it's a constant, so we say 10. Number 2 is negative 3. Number 3 is 4 to the third, or 64. Because these are all constant functions or linear functions, we don't have to use the limit of f of x or the limit of g of x. We do for number 4, and we're going to subtract the limit of g of x minus the limit of f of x. So 0 minus negative 6 gives us positive 6. For 5, we'll multiply them together, and that's 0. For example number 6, the limit as x approaches negative 2 of g of x is 0. So we have a 0 in the denominator, so our limit cannot exist because we've divided by 0. For example number 7, we're adding the two limit values together, so we'll get negative 6. And for 8, we are raising the limit value of g of x to the 7th power. 0 to the 7th power is still 0. All right, let me know if you have any questions.